Okay, lesson 48, indirect proofs. An indirect proof is when you start by saying the statement is assumed to be false. So then you find a contradiction to your false statement to show that it's true. So these are the steps that you want to remember for an indirect proof. You assume the conclusion is false. So you look at the conclusion and say, okay, we're going to assume it's false. Find a theorem or postulate that contradicts the assumption. You can also use a definition or any of the given information. And then you state that your assumption must be false and therefore the conclusion must be true. So let's show me I'm going to show you an example. Okay, here's an example. Prove if two lines intersect, they intersect at exactly one point. So let's assume that it's not true. So we're going to assume that when two lines intersect, they intersect at more than one point. Okay? Assume that lines M and N intersect at 2 points A and B. Okay, so we're just going to say, okay, they're going to intersect at 2 points. This contradicts postulate 5 that states that through any 2 points there exists exactly one line. So between A and B there's only one line, so it can't be intersecting both of them because that would mean 2 lines. Since it's not possible for 2 lines to pass through both points A and B, the assumption made is contradicted and therefore must be correct. Weird, huh?
So you're like solving your own problem?
Mm-hmm. Yeah, you're like going about it indirectly.
So it just proved it right?
It proved that, well, the assumption was contradicted. You assumed that it intersected 2 points, so therefore the statement itself must be correct. What's that? I know, I know. You're right.
That's why we shouldn't do these proofs. We should
We assume, yep, assuming is not always a good thing. Okay. In an indirect proof, drawing a diagram is often helpful. I don't want you guys to be afraid of drawing pictures when you're doing your homework or proofs and stuff like that. Pictures really help so that you can kind of see what they're asking. So here's an example. Use the diagram, so they didn't make you draw it, that's good, to prove if an inscribed angle intercepts a semicircle, then it is a right angle. So they're given your diameter of the circle, we want to prove this. So we're going to assume that it doesn't equal 90 degrees. So by Theorem 47.1, arc ADC, does yours say B? It should say D. Okay, it's supposed to be a DC. So if ABC does not equal 90, then the arc it intercepts, and that's what we did yesterday, would not be 2 times 90, would not be 180 degrees. Since the arc is since it's twice the measure of the inscribed angle. AC is the diameter and goes through the center of the circle. Angle AMC is a straight angle that measures 180 degrees. And since it's a central angle that intercepts arc ADC, it's equal to. The arc is equal to the central angle that intercepts it. You guys remember that from a long time ago? So if this is 180 degrees, the arc is 180 degrees, that just contradicts the assumption, and measure angle ABC is equal to 90 degrees. Okay, so that's the lesson, and we have the practice set on the back of your paper that we'll do.